Alright, hey guys, it's me again, Miss Moncrief, back at you with a new lesson. These are mostly to just help you out in geometry. So before we go any further, today we're looking at simplifying radicals. So before we go into learning how to simplify radicals, let's remember some prime factorization. So first, that just means we want to factor each as the product of prime numbers. So we just want to break it down to all of the prime numbers in that number. So if we have 100, let's do the prime factorization of 100. Well, what's the first prime number we can think of that will divide into 100? That would be 2. And 2 times what? 50. So we have 2 times 50. Now, 2 is prime. What about 50? No, not yet. So let's do it. Let's divide it again by 2 because we know it's even. And then 25. Oh, goodness. 2 and then 25. All right, but is 25 prime? Nope. We have it by a 5 and a 5. You do have to write both 5s down. I don't know why my 5s are looking so ugly today. Oh my gosh. So that would be prime factorization of 100. Now let's look at 54. 54, it's even. So rule of thumb, if it's even, that means the first thing we can do is divide it by 2. So it's 54. That's not 54. 54 divided by, it's not divided by 2. And what do we get? 27. So we got 2 and 27. Now what are some numbers? 27 is no longer prime, but what is another number that goes in 27? That's right, I heard someone say 3. So what's 27 divided by 3? Well, that's 9. So we have 9 and 3. Now what's 9? Can we break 9 down any further than 9 and 1? Yes, 2, 3, 3 and 3. Sorry, the pen was writing all funky. But now all these in a circle. Our goal here is to get all prime numbers in these circles. So that's why we're kind of doing it. So now let's look at 32. Well, it's 32 even. Yeah, so let's divide by 2. 32 divided by 2. And what do we get? 2, which is prime, and 16. Now, what about 16? Is it even? Yeah, so let's go ahead and divide by 2. So we have 2 and 8. Is 8 even? Yeah, let's divide it by 2 again. Oh, 8 divided by, that's 5. 8 divided by 2, that'd be 4. So 4 and 2. And then can we simplify 4 any further? Yeah, to 2 and 2. Remember, prime means the only numbers that can divide into it evenly are 1 and itself. Okay? So now let's go with recalling perfect squares. So we already got a few of them. 1, 4, 9. What's the next one? That would be 16. After 16, we got 25. Again, why are my 2s and 5s looking so ugly today? After 25, we have 36. Then we have 49, 64, 81. I think, yeah, 81, 100, 121, and 144. That'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 through 12. Those are when we multiply all of our numbers 1 through 12 by itself. All right, so now this is going to actually help us when it comes to simplifying radicals. We want to, for A through C, that's these 3 letters, sorry, write each as the product of a perfect square and a number. So that means we just want to find 2 numbers we'll multiply these by that are what we want to, and one of them has to be a perfect square. The best way we're going to do it is go to y equals, and then y1 we're going to do number divided by x. So let's start with A. What's my number? 100, so we'll have 100 divided by x. And then we'll go to our table. So second graph, and we're going to look for the highest. Oh my gosh. I'm just upset that this is writing so ugly. I mean, my handwriting is not great in the first place. Oh, nah. I'm about to just type it. Yeah, we're just going to type it. The highest perfect square. And that's what we're looking for. We're going to take this P, because I don't know why it's there, and delete it. The highest perfect square. So let's go find the highest perfect square for 100. 0 is technically a perfect square, but we can't divide by 0, so moving on. 1's a perfect square. We got 100. But let's keep going. 2 is not a perfect square. 3 is not a perfect square. 4 is a perfect square. And it's got 25. So far, so good. Is 5 a perfect square? No. 6? No. 7? No. 8? No. 9? 10? No. None of those numbers are perfect squares. And we're starting to get into decimal territory. So I think we're good at sticking with that 4 and whatever we had. Please go back up. So what number went with 4? Well, that was 25. So we have 4 times 25. 4 times 25. I would hate to subject you to my continuous handwriting. Right, but now let's check it for 54. It might not be as easy for 54. So again, let's clear this out and do 54 divided by, divided by 54 divided by x, and second graph. Now we want to find the highest perfect square. Let's start with the first perfect square we have, which is 1. Get you 54. Okay, might be it. Now let's go to the next one. 4, get you 13.5 is, but we don't want that because that's not a whole number. Now let's go to the next one. 9. What do we get? 6. All right, so 9 and 6 are looking pretty good. Let's go to 16 now. All right, 16's got a decimal. We don't like it. Let's check out 25. 25 also has a decimal. Don't like it. Let's check out 36. Oh, second graph. 36, and we also have a decimal. So I think our best bet is probably going to be that 9 and, I forgot. 9 and 6. We have 9 and times 6. Now, is 6 a perfect square? No, but that's okay. We don't need it, both of them to be a perfect square. We just want one of them to be. So now let's go check out 32. So cleared out. Let's check out C, which is 32. So 32 divided by x. And we'll go to second graph to get the table. Let's start with all of them. My first one, 1 and 32. It's our default answer. Now let's go to 4. We have 4 and 8. What a lovely couple. That one might work. What's after 4? We get 9. Let's go check out 9. Does 9 get us a decimal? Yeah, boo. We don't care about it. Check out 16. Oop, 16 gets us 2. And like pretty much, we'll go ahead and check 25. See what happens with 25. 16 gets us 2. And then 25 gets us like 1 point something. And the rest of these just look like decimals, except for 32 itself. So definitely our highest perfect square factor is going to be that 16. So we have 16 times 2. Okay. All right, and that's going to go in hand. That's going to help us a lot when it comes to this simplifying radicals. Okay, so we are now simplifying or rationalizing radicals. It's just where, remember when we used to do the square root of 4? You knew that that immediately was what? 2. But now we're going to do things like the square root of 6 and ask you to simplify it. You won't necessarily get rid of the radical, but you might get rid of some numbers inside of it. So let's go. To simplify a radical, factor the expression under the radical sign so it's prime. For every pair of like factors, bring out the factors, multiply whatever is outside the sign, then multiply whatever is inside the sign, remember that for each pair, you bring out only one of the numbers. So for each pair, you only bring out one. So we want to factor the pairs of numbers. We want to factor, then look for pairs of numbers or perfect squares. Since the expressions are equivalent, you can check converting each into a decimal. So let's check it out. The first one we have is the square root of 28. So let's check out some of my factors of the square root of 28. We're going back to doing this prime factorization like what we did at the beginning. So we have 7 and 4. 7 times 4 gives us 28 because we're looking for prime numbers to start. So, and then can we simplify either of those numbers? Yeah, we can simplify 4. How? 2 times 2. So that's how we got it. So now we're at 7 times 2 times 2. What we're going to do is circle a pair. What's the only thing we have paired? Just those 2. So we'll have 2 times the square root of whatever was left over. 7. So 2 times the square root of 7. What we're doing is we're doing prime factorization, circling pairs, putting them on the outside, and leaving what's left over on the inside of the radical. So now let's do the square root of 1, and let's check it out. So let's check out the square root of 28. The second square root 28. That's just 25. 28 is 5.29, blah, 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 blah. Now, I can't write that down as an answer. I don't want that as an answer. We want a more simplified radical, so that's why we did this prime factorization. Let's see if what we did was right by typing in 2 times the square root of 7. So 2 second square root 7. What do we get? 5.29150. We get the same thing. So that means our factorization is simplifying. That means we simplified the radical correctly. All right, so now let's check out B. B is the square root of 150. So let's start with some. Factors of 150. Well, I know for a fact we have 15 and 10. All right, so let's simplify 15. We get 3 and 5. Cool deal. We like to see it. The next one we have 10. Let's factor it. 2 and 5. Are there any numbers that are the same? Yes, they both have. That's the eraser I want, the highlighter. They both have a 5. So we're going to take that pair, and we're going to move one of them on the outside. So we have 5. And then we'll have times the square root of 3 times. If I can write a 3. Again, if I can write a 3, 3 times 2. So what's 3 times 2? Well, that is 6. So 5 times the square root of 6. And there you go. Again, let's check it. So second square root 150. Enter. All right, it's 12.247444871. Now let's check out 5 times the square root of 6. So 5 second square root, not log, 5 second square root 6. And we get 12.247444871. All right, we got the same thing. So we are good. Now let's check out the square root of 720. So let's go ahead and try to take the square root of 720. Maybe it is already perfect. So second square root 720. Oh my gosh, it's not perfect, so that means we gotta simplify it. So let's start with this 72. And so what are some factors of 720? Well, we can easily divide that by 10 and get us 72 and 10. So now let's simplify 72 some more. What does it simplify to? What can we do? Set 9 and 8. Can we simplify either of those numbers some more? Yeah. 9 would be 3 times 3, and 8 would be 2 times 4. I'm going to rewrite this one out because I think there might have been a typo, but I also might just be overthinking it. So we'll have the square root of 720. We know that we have 72 and 10. So let's list out some factors of 72. So 72, we know we can divide it by 9, and we'll get 8. So 9 and 8. Can we simplify that 9 any further? Yeah, to 3 and 3. And then we can simplify that 8 to 4 and 2. Is there anything else we can simplify? Yeah, that 4 to 2 and 2. Cool. So that is down to the primes. Now let's do 10. 10 we can simplify to 5 and 2. All right. So now let's circle any pairs. So we have 3 and 3. There's one pair. We have this 2 and 2. There's another pair. And then we have another 2 and 2. So this time we have multiple pairs. We're just going to bring one of each out. So let's start with the 3. We have 1, 3. Now we have a 2. And now we have another 2. And all times, whatever's left over at the end, which would be that 5. And gosh darn it, I'm not looking forward to drawing that 5. Ooh, not too bad this time. All right, so now that we have this worked out, we're going to multiply everything that's on the outside. So it's 3 times 2 times 2. 3 times 2 times 2. Well, that gets us 12. So we have 12 times the square root of 5. And now let's see what 12 times the square root of 5 is. So we have 12, second square root, and 5. And we'll do good. 26.83281,573. 26.83281,573. All right, we did it. We worked it out. It's great. So our answer is good. And there we go. That is simplifying radicals, and that'll help you a lot in geometry. All right, and now let's go to our next example. Now we are factoring the numbers. Now we're looking at example 2. Example 2 is different from example 1 because now we have variables. So we want to factor the numbers and simplify each as in example 1. So that's just saying if you have a number in it, we're going to do that prime factorization like we did before. And then we want to rewrite the variables as even exponents multiplied by odd exponents and divide the even ones by 2. So it'll make sense as we go along. So let's look at this first one, x cubed. Is there any numbers that we can simplify like we did in example 1? No, so let's keep going. So now it means we have x. So that means we have the square root. And we're going to do this second part. Rewrite the variables as even exponents multiplied by odd exponents. Remember, when we do this, because we're adding, it's x times another x. What do we do with these exponents? Like b and c. We'll add them. So it would be x is equal to b plus c. Why is this writing? Sorry. Okay. But yeah, remember when we're just expanding it to what we learned before. So what's an even number that will add to get us 3? Well, that's 2, so x squared, and what plus 2 gets us 3. So x squared times x to the first, because 2 plus 1 is 3. Now what we're going to do is divide this by 2. So what's 2 divided by 2? Well, that would be, I'm so mad. 2 divided by 2, well, that would be 1. So that means my new exponent on the outside is going to be 1. So I'll have x to the first power times the square root of whatever was left over. So what was left over? X. So we have x times the square root of x. And yeah. So now let's check out the second one. So we have 54, or the square root of 54x to the 7th. So let's simplify that 54 first. So we have 54. Again, let's start by dividing it by 2. Divide by 2. All right, so we have 2 and 27. Let's simplify 2 and 27. Can we simplify 2 any further? No. For 7, we can simplify 9 and 3. Simplify any of these? Yeah, 9. 3 and... Oh my god. 3 and 3. Got any pairs? Yes, we have this 3 right here. So we know there's going to be a 3 on the outside. So we have 3 times the square root of what's left over. 2 times 3 is 6. All right, and now let's look at x to the 7th. What's the highest even number that will add to 7? That would be 6, because 6 plus 1 is 7. So we have x to the 6th times x to the first power. So now we want to divide that even exponent by what? 2. So 6 divided by 2 is 3. Is 3. So that means we have 3 times x cubed, because we divided it by 2 and got 3, times the square root of 6 times x to the first. And we're done. All right, and now let's check out the next one. Let's start by simplifying that 80. So 80, we know we have 2 off the top of my head, 8 and 10. What number is going to 8? 2 and 4. What number is going to 4? 2 and 2. Now let's check out 10. We have 2 and 5. And then let's see what numbers match. Let's go from left to right. We got 2 and 2, so we know we have one set of 2s. And we got 2 and 2, so we got 2 sets of 2. So 2 times 2. So we have negative x times 2 times the square root of what's left inside of that prime factorization, 5. So 5. And then what's the highest number that will add to get us 9? That'd be 8. So x to the 8. Sorry, I need more room. So x to the 8 times x to the first. And then what's the highest even number that will add to get us 2? Well, that is 2 and 0, so y squared. So now let's divide all of those even exponents. Let's divide all those even exponents. So, trying to make that. Why? So now let's divide all those even exponents. We have 8 divided by 2, which will get us 4. So now we have everything on the outside, negative x times 2 times x to the 4th. And then what's 2 divided by 2? Well, that'll be 1. So we have y to the 1st. And then we'll have stuff on the inside. So we'll stop the 5 and whatever is left over of those x's. 5 and just x. Now we got to simplify that outside. We have a negative times a 2, so that's a negative 2. X times x to the 4th, so that would be x to the 5th. Y times the square root of 5 x. So negative 2 x to the 5th y times the square root of 5 x. And I'm certain if you have any questions, your teacher would love to help you. And now I have to remember how to stop this.